Hi guys, in today's video I'm going to be continuing with the AP Calculus BC syllabus. I'm going to be discussing absolute and conditional convergence. So let's get started. So if n equals 1, infinity an converges and n equals 1, infinity, absolute value of an also converges, then it is absolutely convergent. So when both converge, it's absolutely convergent, and when n equals 1, infinity an converges, but n equals 1, infinity, absolute value of an diverges, then it is conditionally convergent. Okay, so now let's get started with a few questions. So we have to find out whether they converge or diverge. And if we need to find out whether the series converges or diverges, and if it converges, we have to find out if it converges absolutely or conditionally. So we have n equals 1, infinity minus 1 to the power of n divided by root of n. So what we do is, we can use the alternating series test, as we can see that this series alternates as there's a negative 1 to the power of n. An would be equal to 1 over root n. Limit n tends to infinity. 1 over root n is 1 over infinity, which is 0. So this condition holds true. And then an plus 1 should be less than an. That is our second condition, and that also holds true in this case when we use 1 over root n. So we know that this series converges. Now that it converges, we need to find out if it converges conditionally or absolutely. So what we do is we have to find out whether n equals 1, infinity, absolute value of an, so it's just 1 over root n. We need to find out if this converges or diverges. So this can be written as 1 over n to the power of 1 by 2. And we know that in a p series test is expressed as 1 over n to the power of p. P is 1 over 2 in this case, and 1 over 2 is less than or equal to 1. So it diverges. So absolute value of an diverges by the p series test. So because n equals 1, infinity an converges, but the absolute value diverges, we know that n equals 1, infinity an is conditionally convergent. Because one converges while the other one diverges. Now let's look at another example. N equals 1, infinity minus 1 to the power of n plus 1 divided by cube root of n. So it alternates because we can clearly see that there's an alternating series as we have minus 1 to the power of n plus 1. So an is 1 over cube root of n. We need to find the limit n tends to infinity of 1 over cube root of n. And this is 1 over infinity, so it's 0. This condition holds true. Secondly, an plus 1 is less than an, so this also holds true. Hence, n equals 1, infinity, an converges. Now that it converges, we need to find out if it converges absolutely or conditionally. So we need to find out if n equals 1, infinity 1 over cube root of n converges or diverges. This can be written as 1 over n to the power of 1 over 3. And by the p-series test, p is equal to 1 over 3, which is less than equal to 1. So it diverges. So the absolute value of an diverges. Because one converges and one diverges, it is conditionally convergent. So that's how easy it is. Okay, that's it for today's video, guys. In today's video, I discussed absolute and conditional convergence. Thank you. Hope you all like and subscribe. And please consider subscribing to this video as it helps me out a lot. Thank you.